Hello student. Today I am going to start oxide of sulfur. Generally two type oxide of sulfur. First is sulfur dioxide SO2. Sulfur dioxide SO2. Second is a sulfur trioxide. Sulfur dioxide structures is this is a structures of sulfur dioxide. SO2 is a gas and also acidic in a nature. Sulfur dioxide is gas and also acidic in nature. Preparation of sulfur dioxide. The preparation of sulfur dioxide process, various process. Number 1, oxidation of sulfur. Sulfur oxidize in air by the oxygen and form sulfur dioxide. Second is a laboratory process. In laboratory, sodium sulfide Na2SO3 react with sulfuric acid. The product is sodium sulfate plus water and also sulfur dioxide gas. That is the laboratory process. Next is a popular reactions is the copper not displace hydrogen from sulfuric acid, but it react with sulfuric acid and form copper sulfate plus water molecules and also sulfur dioxide gas. Number 4, preparation of sulfur dioxide is industrial purpose. All sulfide ores during the roasting process, two processes, one is a calcination, second is a roasting, release of sulfur dioxide, 4 valence, 2 ZnS, 2 ZnO, 2 SO2 and here is 3 O2. All sulfide ores during the roasting process release of sulfur dioxide. In a contact process also, iron pyrite is FeS2 plus 11O2. The product is 2Fe2O3 ferric oxide plus 4,2J8, 8 molecules of sulfur dioxide. The various process of the preparation of sulfur dioxide. First, why the direct oxidation of sulfur? Second is a sulfide with sulfuric acid. Third is copper with sulfuric acid. Next is a industrial purpose. Zinc sulfide means all sulfide ores, release of sulfur dioxide gas. Next is a in a contact process, iron pyrite is on oxidation, release of sulfur dioxide gas. The physical properties of sulfur dioxide gas is the sulfur dioxide gases in a nature, but it is a colorless. Second is a toxic in a nature. Next is it have the pungent smell and suffocating odor. The sulfur dioxide colorless, toxic, pungent smell and suffocating odor. Next is a 1 volume of water dissolve 8 volume of sulfur dioxide gas. It means SO2 more soluble in water. 1 volume of water dissolve 8 volume of sulfur dioxide gas. It means the sulfur dioxide gas is a more soluble in water. The chemical behavior or chemical properties of sulfur dioxide gas. Number 1, it is a acidic in a nature. Acidic in a nature. When sulfur dioxide gas pass in a water, it change into sulfurous acid. The sulfurous acid is a dibasic acid in a nature because it have two OH linkage and release of two hydrogen ion and form SO3 sulfide ions. Sulfide ions. Then blue litmus paper turn into red color. Then sulfur dioxide and also aqueous solution acidic in a nature. Next is a reaction with base. Two is a popular base. One is a sodium hydroxide with SO2. The sulfur dioxide gas, when passed in a sodium hydroxide aqueous solution, it forms sodium sulfide plus H2O. If the continuous gas is a pass of sulfur dioxide, what will happen? The sulfur dioxide gas again react and form is 2NaHSO3 sodium hydrogen sulfide. In case of calcium hydroxide, the reactions of calcium hydroxide with sulfur dioxide similar to carbon dioxide. In carbon dioxide gas, when carbon dioxide gas pass in a lime water, what will happen? Milky color appear in a test tube due to formation of calcium carbonate. If the continuous is carbon dioxide gas pass, what will happen? The milkiness of solution disappear due to formation of calcium hydrogen carbonate. In case of sulfur dioxide gas, when sulfur dioxide gas pass in a lime water, it react with and form is a calcium sulfide CaSO3 plus H2O. If the continuous gas is a pass, calcium sulfide react with SO2 and change into calcium hydrogen sulfide. The calcium sulfide appear is a milkiness precipitate. When SO2 gas continuous pass, it change into colorless solution just like to calcium hydrogen carbonate. It means 2 is the most popular reactivity with base. One is a sodium hydroxide, second is a with calcium hydroxide. Third is a reaction with oxygen. In a contact process, we also know the sulfur dioxide react with oxygen in the presence of the vanadium pentaoxide. The optimum temperature is 720 Kelvin and pressure is at 2 to 3 bar. The sulfur dioxide oxidizes in a sulfur trioxide gas, and sulfur dioxide gas used for preparation of sulfuric acid. Number 4, reactivity with carbon and magnesium. The sulfur dioxide गैस कम्बिशन प्रोसेस में हेल्प नहीं करती है. नॉट जो आपका कम्बिशन प्रोसेस होता है जैसे कार्बन चेंज इनटू कार्बन डाइऑक्साइड, मैग्नीशियम टू मैग्नीशियम ऑक्साइड, it not help in a combustion process. But in case of the carbon and magnesium, the carbon is oxidized, carbon dioxide and sulfur. Magnesium more reactive for towards side of oxygen, it change into magnesium oxide and sulfur. It means only sulfur dioxide help in a combustion process of carbon and magnesium, but actually the carbon dioxide not combustible gas and also not help in a combustion process, but in case of only carbon and magnesium. Next is with H2S. H2S plus SO2. The product is definitely two molecules of water plus sulfur. It means sulfur dioxide to sulfur. Just like to formation of colloidal solution of sulfur. The most important reactions of sulfur dioxide is as a reducing agent. In 11th class, we are study of the redox reactions. Two is a process, one is a oxidation, second is a reduction. The oxidation means we explain by the two step. Sulfur dioxide SO2. The oxidation number sulfur is in SO2 plus 4. Sulfur dioxide to sulfate ions SO4. The oxidation number is plus 6. It means the sulfur change into plus 4 tetravalent to hexavalent by the release of 2 electrons. In case of potassium permanganate KMnO4, permanganate ions MnO4 1 negative. The manganese in permanganate ions heptavalent. It reduces in a heptavalent to divalent. It means heptavalent manganese reduces in a divalent. The required electrons is 5. In case of first step, the release electrons only 2. In step second, use electrons in a reduction process 5. For valence, first equation multiple by the 5 and second multiple by the 2. Then MnO4 1 negative 2 MnO4 plus 5 SO2 change into 2 Mn divalent plus 5 SO4 divalent sulfate ions. The number of oxygen 4 to the 8, 5 to the 10, 10 plus 8, 18, then plus 2H2O. The oxygen is a balance. The hydrogen left side is a 4, but right side is a 0. In a acidic media, the hydrogen balanced by the hydrogen ions. That is the reducing nature of sulfur dioxide, whereas manganese heptavalent oxidized in manganese divalent. Number 1. Number 2. Again, in case of sulfur dioxide SO2 tetravalent oxidized sulfate ions hexavalent, release electrons only 2. Potassium dichromate case Cr2O7 divalent. The oxidation number of chromium in dichromate ions is plus 6. After reductions, chromium hexavalent reduced in chromium trivalent. The required electrons hexavalent to trivalent only 3 electrons. What coefficient here? 2. When coefficient is 2, then required electron 2 times. Then 6 electrons. In step number 1, only release 2 electrons. Step number 2, utilize of 6 electron. Then equation number 1, multiple by the 3 and valence. Try to 6 electrons cancel. Dichromate ions Cr2O7 2 negative plus 3 SO2 change into 3 SO4 sulfate ions plus 2 chromium ions. The first is observe the number of oxygen. Both side is a valence, yes or no? The right side oxygen is a 3 4 12 and left side 3 2 6. 6 plus 7, 7 plus 6 is a 13. Then one oxygen less than in a right side, then added is a one oxygen by the form of H2. The number of hydrogen right side is a 2 but left side is a 0. Then left side added is a 2H. And that is the another example of redox reactions where chromium hexavalent oxidize hexavalent to trivalent and sulfur oxidize tetravalent to hexavalent. And total reactions here Cr2O7 divalent plus 3SO2 plus 2 hydrogen ion. Product is 3 sulfate ions, 2 chromium trivalent plus water molecules. Number third oxidation reactions. SO2 step number 1 tetravalent to sulfate hexavalent. The release electrons only 2. In potassium iodate ions KiO3 iodate ions, IO3 iodate ions to iodine. Step second, the iodine oxidation number in iodate ions 3 2 is 6, 6 में से 1 जाएगा बेटा कितना बचेगा 5. It means the plus 5 oxidation number of iodine in iodate ions. Plus 5 to oxidation number is 0 because the molecules in molecules the oxidation number of atom always 0. Plus 5 to 0 required is a 5 electrons, but coefficient is a 2. Their total electrons required pentavalent to 0 valent is a 10 electrons. In step number 1 A, only 2 electrons released, then this equation multiplied by the 5 and both A and B is a combined. In a first step, release electrons 10 and utilize electron 10, both side electrons is a cancel. The next is a iodate ions IO3 1 negative plus 5 SO2 molecules. The product here 5 sulfate ions divalent and 1 iodine molecules. In this reactions, the number of oxygen first is a valence. The number of oxygen 5 4s are 20. But left side is 5 2s are 10 plus 3 only is 13. Then the balance of reactions number of oxygen by the molecules of water required is a 7H2 and here is number of hydrogen is 14H. Then this reactions is a balance. Again is this is in this reactions 2 is a balance as 2 iodate ions I2 है ना यहाँ पर 2 iodate ions, then here is 2. The number of oxygen is 5 2 is 10, 10 plus 6 16, 16. Then required only 4 H2. Then number of hydrogen here is 8. आयोडीन मॉलिक्यूल्स कोएफिशिएंट इसका 2 मॉलिक्यूल्स है ना, तो 2 का मल्टीपल करना पड़ेगा है ना, तो 2 आयोडेट आयंस प्लस 5 SO2 प्रोडक्ट इज 5 सल्फेट आयंस प्लस I2, 2 का मल्टीपल किया तो 6 हो गया, 10 प्लस 6 is 16, 5 4 is 20, then only 4H2 8H. Next is the SO2 plus reaction with moisture and product is a H2SO4 plus 2 nascent or atomic hydrogen. The atomic hydrogen react with Cl2 and product is a 2HCl, Vr2 plus 2H. The product is a 2HBr. Next is a Fe2SO4 whole 3 ferric sulfate plus 2 hydrogen 2 FeSO4 ferrous sulfate plus H2SO4. This hydrogen used in the reactions 2H, 2H and also 2H. Next is a sulfur dioxide plus moisture 2 H2SO4 plus 2 atomic hydrogen. The 2 hydrogen used in a reactions Cl2 to 2HCl, Vr2 2H Vr and ferric sulfate to ferrous sulfate. In case of air, Cl2 is a zero valent. In HCl, chloride is a negative. One carry negative charge. It means chlorine accept of the one electrons. Vr2, bromine is a zero valent. In HBr, bromine is a one negative charge, monovalent anions. Fe2SO4 का whole 3 iron is a trivalent, but in a ferrous sulfate iron is a divalent. It means chlorine reduced in a chloride ions, bromine reduced in a bromide ions, and ferrous reduced in a ferric reduced in a ferrous ion. With peroxide reaction, it is easy reaction. PbO2 plus SO2. The product is a PbSO4. Sodium peroxide Na2O2 plus sulfur dioxide. It means the peroxide to sulfate. Lead peroxide, lead sulfate. Sodium peroxide, sodium sulfate. Next is the most popular topic is bleaching nature of sulfur dioxide. What is the means of bleaching nature? The color compound change into colorless, that is called bleaching action. Sulfur dioxide react with moisture and form is a product sulfuric acid and release two nascent or atomic hydrogen. Colorful substance pillar nascent hydrogen. The colorful substance change into colorless substance, that is called bleaching action of sulfur dioxide gas. Sulfur dioxide gas react with moisture H2O and release of two nascent or atomic hydrogen. The colorless substance, when react of this nascent hydrogen or atomic hydrogen, it change into colorful substance to colorless substance. It is called bleaching action of sulfur dioxide gas. But this action is a temporary. This action is a temporary. Why this action is a temporary? Because the colorless substance restore their color and change into colorful substance. Why the air? It means The bleaching action of sulfur dioxide is a temporary action because again colorless substance restore their color in the presence of oxygen or air. Structures of sulfur dioxide. The atomic number of sulfur is 16. 2, 8, 6. Outer cell is a third. K, L and outer cell. S, P and bracket is a 3D. 3S, 3P and 3D. S is a carry 2 electrons. P is carry 4 electrons. S2, P4, D0. The total electrons unpaired in ground state only 2. Then oxidation state plus 2. In the presence of oxygen, the required energy for jump from p orbit to d orbit. The sufficient energy available in the presence of d in the presence of oxygen, the 1 electrons from p jump from p orbital to d orbital. The total electrons unpaired here 4. Then this is called excited state, and number of electrons unpaired 4. Then oxidation state are number plus 4. S is carry electrons pair, P carry 3 unpaired electrons and D is also carry 1 unpaired electrons. Then S, 3P and 1D overlap and form is a new set of the orbital. It is called sp3d hybrid orbital. In sp3d hybrid orbital, one sp3d hybrid orbital carry lone pair of electrons and remain 4 sp3d hybrid orbital carry 1 electrons. Second is oxygen. Atomic number 8. 1s2, 2s2, 2px2, py1 and pz1. The oxygen atomic number 8. First cell carry 2 electron, second cell carries a 6 electron. In 6 electron outer cell, 2s carry 2 electron, 2px carry 2 electrons, py1 and also pz1. It means the oxygen carry 2 unpaired electrons in a py and pz atomic orbital. The oxygen capable to making up double bond. The sulfur sp3 hybrid state, sp3d hybrid state. यह बेटा हम रिप्रेजेंट करेंगे S की sp3d hybrid state को. In sp3d hybrid state, one sp3d carries a 1 electrons pair and 4 is carry 1 electrons. and oxygen carries a one electrons unpair in py and one electron in a pz. Py and pz, that is the unpaired electron, the unpaired electron of oxygen. This oxygen pz orbital overlap with sp3d orbital of sulfur, and this is sulfur 1 sp3d carries a lone pair of electron and bonded with one oxygen through the sigma bond. Number next, second oxygen is also bonded with sulfur through the sigma bond, and each oxygen carries a one electrons in also py atomic orbital. The py atomic orbital participate overlapping with orbital of sulfur, and this is a pi bonding between oxygen and sulfur. And this is called and another is p pi d pi, and the bond angle is 119.5 degree, and bond length is a 143 picometer. This is the structures of sulfur dioxide. In case of sulfur dioxide, two type pi bonding. First is a second p pi एंड d pi. ऐसा क्यों कह रहे हैं हम? क्योंकि आपका एक जो ऑर्बिटल है वो कौन सा है? d का है. But in case of generally hybridization, we are not count of s, px, py, pz or d. But for explanation, the pi two type p pi and p pi dash d pi bond.